First one's 2. Second one's 3. Start 1, 2.
Okay, let's come together and take a peek. I obviously always hear the group here in the front, but AC said something like trinomials is 3 terms, right? I mean, that's easy. If you're going to factor a trinomial, it means you started with something that had 3 terms. So use this method when you have 3 terms. Okay? And so when you look at it, it's like, when I'm asking about the terms, I'm talking about like the standard form of the polynomial, so before it gets factored. Okay? So it has like an x squared, an x, and a constant term. Those are the 3 different terms. What did you say for difference of perfect squares? How many terms would you have in the original polynomial? Any groups put any numbers out there? Here's the factored side. Here's the polynomial. How many terms does it have? 2. So if you have 2 terms, you might check for difference of perfect squares. Like, are all of the terms or all of the parts of the terms perfect squares? Okay. How many terms would you have for the difference or the sum of perfect cubes? How many do you have? 2 terms. An a cubed and a b cubed, whether they're being added or subtracted, but you start with 2 terms. So think about this. When you come up to a factoring problem, should I use the difference of perfect squares or the difference of perfect cubes? Well, that depends on what kind of numbers you have. So it's not like you'll always know based on the number what type of factoring to use, but it kind of narrows it down. Like, these are options that I have to factor things with 2 terms. Okay, if they fit the requirements. And what about grouping? How many terms would you have? It's kind of a strange one. Factor by grouping, you need 4 terms, because you should have done factor by grouping in Algebra 1, and what you do is you split it 2 and 2, and you work with like 2 terms at a time. Okay, instead of working with 4 terms, you do 2 terms at a time. So this is when you have 4 terms. AC, you want to put away your phone for me, please? Okay, so those are like things that you can use to help, like how would I decide to factor, like which type of method I might use, can be based on the number of terms that you have. Maybe highlight, if you've got a highlighter, or star, circle, underline. It says it in the middle in bold, but it's something that often gets overlooked. Check to see if you have a GCF. What do I mean by GCF? Greatest common factor. So do all 2 terms share something in common, a number or an x or something like that? Do all 3 terms share something in common? Do all 4 terms share something in common? You can only take out the greatest common factor if all the terms in the polynomial share some number value, like they're all even, so I can take out a 2, or they're all multiples of 3, so I can take out a 3, or maybe they all have an x, so I can take out an x. Okay, so we're going to go through the 4 different types of factoring. Some of them should seem familiar to you. I'm going to go on to a different slide so I have more space to write, so I just took a quick picture of, I think I start with the difference of perfect squares. Okay. So in the difference of perfect squares, okay, these 2 pieces right here, a squared and b squared, must be perfect squares. You can't use the difference of perfect squares if any part of your 2 terms is not a perfect square. So let's see if we can create a list of perfect squares. What are some number perfect squares? 4, 16, 9, 36, 64, 25, 49, 81, 100,
121.
121, 144. Does anybody remember from geometry? You spent a lot of time with squares when you did Pythagorean theorem. 169 is 13 squared. 196 is 14 squared. 225. 256, and that's kind of where I'm like, okay, then I have to start looking up 17 squared or 18 squared or 19 squared, but you might actually even remember them from geometry. Yeah, there's a 324, I think that's 18 squared. I can't ever remember what 17 squared is. 289 maybe?
Yeah.
Okay. What one are we missing? The very front? Often overlooked? 1. It's a perfect square. Okay, so you can, if you see any of these numbers as coefficients to your first term or your second term, like that counts as a perfect square. But you may also see things that are perfect squares that are written as variables. So think about like what would perfect squares as variables be? X squared is a perfect square because what's its square root? X to the first. X to the fourth is a perfect square because what's its square root? X squared. It was x squared times x squared. I added my exponents and it was x to the fourth. So the next perfect square would be x to the 6th, x to the 8th, x to the 10th. Basically, if your x has an even exponent, it's a perfect square, right? Because the square root of that is just half of what that exponent was because you would have added your exponents together. Okay, so we've got one example here, I think. We've got 121x squared minus 1 that we want to factor. And the thing to remember about the difference of perfect squares is when you're talking about a and b over here, a and b are the square root values. So a squared is the perfect square. You want to use its square root when you factor it. So what is the square root of 121? 11. And the square root of x squared? X. So the first terms where I would see a, it would be 11x in both parentheses. And what would my second term be, my b value? Just 1. So we have 11x plus 1. And 11x minus 1. Okay, what I want you to do, I think there's a little bit of space there. That's factored, right? It's just done. Okay. I want you and your group to come up with a difference of perfect squares that you could factor. Okay, so you've got a whole list of perfect squares that we created, the red and the blue number values up at the top. Will you and your groups create a perfect difference of perfect squares that you could factor? I'm going to come over and ask your group what you guys decided to do. So pick some numbers, pick some x's, see if you could factor. What do you want to do?
Oh, I see what you meant. Well, I don't think the 4 is. Well, no, because it's got to be, we're doing perfect squares, not perfect cubes. Or perfect one-dimensional objects. I did 64x squared minus 4 just because I don't want to get into the x to this.
That's the sum of perfect squares, which
So
doesn't
would it
have
be
to have
8x plus 2,
4 x
8x
to the
minus
4th
2, or 8x plus 4?
minus the difference of perfect squares. Difference implies subtraction.
The b value is the 4. B value is the 4 for the lower.
Did you guys pick some values to factor?
So I did.
64 x squared minus
Is that
4.
correct? Okay. So it is the
Yes, difference in
minus 1.
what you're going to do.
Minus 4 is plus 2 minus 2.
So then what 2 was?
2 would be.
So wouldn't it go to 8x
That'd
plus
be,
3 and then 8x minus 3? 4.
Alex, was this your guys' x squared or x to the 4th?
X squared. I think they split into 2. Well, she's had because this one with minus 1.
Plus would imply it
Well,
was
because 1 squared is just 1 times 1. Oh, we're doing the squares. We're doing
squared minus 4.
okay, so when you multiply you get a squared minus b plus b. Okay, I think I kind of understand. I mean, not really, but like.
Okay, over here on this sideboard, I've got the 5 different ones. I think that we're around the room. We've got 6 pods, but 2 people chose the same values. So we had a 16x squared minus 1. Okay. One thing that I had to clarify for a few groups, and I didn't mention this when we were taking the notes, that's pretty important, is this is called factoring for a difference of perfect squares. So difference in math means minus. It has to be 2 perfect squares that are being subtracted. If you see 2 perfect squares that are being added, it does not factor. Okay, not factorable. So this is only for the difference of perfect squares. So we have 16x squared. What's its square root? 4x. And then it's being minus, so it's a difference. What's the square root of 1? 1. So we have 4x plus 1 and 4x minus 1. It does not matter in which order you write the plus or minus, right? Multiplication is commutative, so you're okay. I'm going to jump down to this one, 64x squared minus 9. What's the square root of 64x squared? 8x. What's the square root of 9? 3. So you have an 8x plus 3 and an 8x minus 3. Now, there's one reason why I skipped the other 3 that are on the board, because there are multiple ways for you to start factoring those. Why can we start factoring in different methods for 64x squared minus 4, 16x squared minus 4, and 4x to the 4th minus 36? What's weird about all of those? They have a greatest common factor. So if you want to start with difference of perfect squares, you can, or you can start with the greatest common factor. So I'm going to do I'll do 16x to the 4th with difference of perfect squares first. What's the square root of 16x squared? 4x. And what's the square root of 4? 2. So we have one that's a plus and one that's a minus. Well, now when you look at your 2 factors, can you factor the factors? Yeah, 4 and 2 share a common factor of 2. So I could really take a 2 out of this one, which would be 2x minus 1, and a 2 out of the other factor, which would be 2 times 2x plus 1, and then 2 times 2 would really be 4. So 4 times 2x minus 1 and times 2x plus 1, not another 4. Okay. Now, if we had done what Lauren said, which was the difference of the factoring out the greatest common factor, what do 16 and 4 share originally? 4, so we'll take the 4 out of both of them. That leaves me with 4x squared minus 1. What's the square root of 4x squared? 2x. What's the square root of 1? 1. So isn't that 4 times 2x plus 1, 2x minus 1?
Yeah.
Okay, so which method would you like to do?
Honestly, the difference of perfect squares.
Well, I'm okay if you do the difference of perfect squares, but do you also notice how easy it would be for you to stop at 4x plus 2, 4x minus 2, and not keep factoring? When you factor for me, if the problem is asking you to completely factor, that means for 4x minus 2, 4x plus 2, you have to take those 2 2's out, which really makes it a 4. For me personally, I just check for a greatest common factor my first step. So when I get to one like 4x to the 4th, and I like this one because they chose something other than x squared, so they made it a little more challenging. 4x to the 4th minus 36, I notice right away they both have a factor of 4. So I'm going to take a 4 out of both. That leaves me with x squared minus 9, and then I'll have 4 times x plus 3, x minus 3.
Wouldn't it be 4 times x to the power of 4?
Oh yeah, sorry.
Okay.
After I said that I liked that they did x to the 4th, then I messed it up, right? X to the 4th, so it's x squared and x squared. If you ever have something like that where it's x to the 4th in the original and then your factors are x squareds, you would have to check this one that has the minus. They're these perfect squares again. Well, x squared is a perfect square, but
Not
3 is not, so then I'm done factoring. And I would do the same for this one. I would take out the 4 from both of them. That leaves me with 16x squared minus 1. And then we already factored that. That's 4x plus 1 and 4x minus 1. Okay? So if you want some extra examples, you can jot some of those down into your notes. All right. Sum and difference of perfect cubes. Now this one is probably new to you. Does anybody know if you have seen the sum and difference of cubes before? I'm guessing that this one is probably new. Think about how this one is different from the perfect squares. In the perfect squares, you had to have what mathematical operation? Had to be subtraction, right? Only the difference of perfect squares will factor. X squared plus 4 does not factor because x plus 2x plus 2 is really x squared plus 4x plus 4. It has a middle term. Okay, so it doesn't factor if it's x squared plus 4. But with this one, it's the sum and difference of perfect cubes. So that means it could be subtraction or adding perfect cubes. Like we did for perfect squares, let's generate a list. What are some perfect cubes that you know? Eight is 2 times 2 times 2. 27 is 3 cubed. 1 is 1 cubed, of course. What would 4 cubed be? 64. So notice 64 is a perfect square and a perfect cube. 125 is 5 cubed. And then 6 cubed is 216. I generally would say, like, if I were asking you to go no calculator, that's probably as high as I would go. Like, you could figure that out. That's 36 times 6. If you want to list some more, you can. I'm pretty sure 7 cubed is 343. I would have to have someone check in their calculators.
Yes,
Is it?
I do know that one.
Okay, is 8 cubed 520, 512? 512. 9 cubed is 729, and of course 10 cubed is 1,000. But again, I would probably say like 216 is where I expect you to go up to. What would be some x's that are perfect cube? X cubed, obviously. Then the next one would be x to the 6th. Because what's the cube root of x to the 6th? X squared. X squared times x squared times x squared. I would add up all those exponents and that would equal 6. And so the next one will be x to the 9th, x to the 12th, so on and so on. So before, when it was a perfect square, it had to be an even number divisible by 2. Now if it wants to be a perfect cube, your exponent has to be divisible by 3. And then whatever that divisible by 3 is, that's your cube root. Okay, so then notice you have these two like patterns, okay? And this I'm just going to say like this is given to us. It's a formula that works. If we like FOIL it back out, it will equal a cubed minus b cubed or a cubed plus b cubed. You'll have to practice learning these. So if you learn by rewriting, maybe you rewrite the formulas a few times. If you learn by saying it out loud, then you repeat it to yourself a few times. If you need to put a Post-it on your bathroom mirror where you brush your teeth every morning and night, and you look at the sum and difference of cubes, you could do that, right? Or make flashcards for yourself, whatever you want to know, or whatever you want to do. So you got to know those. But I will tell you this. Look at those two patterns. There are some similarities and differences. The similarity is what the terms are, right? A, B, A squared, AB, B squared. Do you agree with that?
Yeah.
Okay, so if you know the terms A, B, A squared, AB, B squared, you got that part down. Okay. For the signs that go in between the terms, I use SOAP. And what SOAP means is same, opposite, always positive. So, like sometimes it's hard to remember things, so you make like clever little ways to remember. I have a few of those in math. And SOAP is one of the ways that I always remember to sum and difference of cubes. So if I'm doing like a sum of cubes, okay, so it's two perfect cubes, A cubed and B cubed are perfect cubes. I know that when it factors, I have an A and a B, an A squared, an AB, and a B squared. Like I know those terms. After I practice, you'll get better at that, like what the terms are going to be. This is the first time you're seeing it, so you're like, I don't know that I would remember that, but eventually you will. And then for the signs in between the terms, it starts with the same sign. Since this was a plus, I'll put a plus. Then the next one is the opposite. So in between A squared and AB is going to be a minus. And the last one is always positive. Never have to second guess it. It's going to be a plus. And look back at the A cubed minus B cubed. It has the same sign subtraction, and then the opposite sign plus, and then it's always positive, so it's plus at the end. So that's a clever little way to remember it if you can remember SOAP. Same, opposite, always positive. Okay. Let's do x cubed plus 64. Is x cubed a perfect square? Perfect cube? Yeah. Is 64 a perfect cube? Yeah, what are the cube roots of x cubed? X and 64? 4. So those are our A and our B values, right? A is x, B is 4. Because this is A cubed and this is B cubed. So then we know that A is equal to x and B is equal to 4. So then I just have to plug them in accordingly. This is going to be A plus B. And then we're going to have an A squared minus AB plus B squared. So I just plug in. Well, that's going to be x plus 4. In the trinomial, it'll be x squared minus 4x plus 16. Notice that for AB, I wrote it as really, I guess, BA, because that's how we normally write coefficients and variables, as 4x instead of x4. Factored. If you took the time to distribute all of this, so you distribute x to all three terms, you distribute -4 to all the three terms, everything will cancel out except for an x squared plus 64. Okay, so it factors nicely. This factor is really nice, x plus 4. This factor back here with the quadratic, x squared minus 4x plus 16. Just a little trip down memory lane here to chapter 3 when we were solving quadratic. If I do my discriminant, b squared minus 4ac, that would be a -4 squared minus 4 times 1 times 64. 16, I'm thinking ahead. Okay, so that's 16 minus 64, which is some negative number, right? -48. So what do we know about our two solutions right there? If your discriminant is negative. There are two imaginary solutions. Okay, so that's something that we'll kind of see later on in this chapter with this sum and difference of perfect cubes. Every time you factor with the sum or difference of perfect cubes, that second one that's quadratic, it produces imaginary solutions. Never will it ever give you real solutions. Okay, so they will always be imaginary. Okay. What do you notice about the second example that I have there? Negative 16x to the fifth and plus 250x squared. Are either of those numbers on the list of perfect cubes? No. Are either of those x's on the list of perfect cubes? No. And like maybe 16 is on a perfect square and x squared is on a perfect square, but the other numbers aren't. So before I give up on this, what should I check for? Greatest common factor. What can you take out of negative 16 and 250? Well, 250 is not divisible by 4. I can tell because if your last two digits are not divisible by 4, then your number isn't divisible by 4. So 50 is not divisible by 4. 2. Yeah. And would you be okay with this? Could I take out a negative 2? Would that be fine? That way my first term isn't negative. If you want to leave your first term negative, you could. But I usually like my first term to be positives, remember, when I'm factoring. So I'm going to take out a negative 2. Can I take anything else out of those two terms? X squared. Now think about what's left over. Negative 16 divided by negative 2 is 8. X to the fifth divided by x squared. Subtract your exponents. X cubed. Positive 250 divided by negative 2. Negative 125. X squared divided by x squared. Gone. Now that you've taken out a greatest common factor, can you factor that two terms by difference of perfect squares or sum or difference of cubes? Yeah, it's a difference of cubes. What is your A on this one? 2. What's the cube root of 8x cubed? Just 2? 2x. What's your B? 5. You don't need to worry about the sign as like a negative 5 because the SOAP, same opposite always positive, that does all the sign work for you. So you just really need like what's the cube root of 8x cubed? What's the cube root of 125? And plug them into your difference of perfect cube. So that's the same sign, the opposite sign, and always positive. So I'm following the formula that you have at the top. Well, that would be what? 2x minus 5? Be careful right here. If you square all of A, what do you get? 4x. This is like 2x squared, which is 2x times 2x. So that's a 4x squared plus 10x plus 25. If I took the time to do the discriminant, it would come up negative, and there are two imaginary solutions to that last factor. This is going to be a place where a lot of people make a mistake, right? So it's like getting used to that with this difference of sum and difference of cubes. They have to square the whole A, which would be the coefficient and the variable, if there is one. That kind of goes back to what we did too with Pascal's triangle, if our first term was a coefficient and a variable. Okay? Any questions on sum and difference of cubes? Kenzie?
Why is A 2x and B is 1?
It's the cube root, so like the first term right here, this is your A cubed, and then this is your B cubed. So just like in the difference of perfect squares, remember A squared was a perfect square, and B squared was a perfect square, and A and B were their square roots. Now we're saying A cubed is a perfect cube, B cubed is a perfect cube. Like the first term is a perfect cube, the second term is a perfect cube. When I'm plugging into the formula, I should be using their cube roots. So anytime you have one that has a coefficient and a variable, it's going to have a coefficient and a variable cube root. Okay, let's move on to factor by grouping. What the little bubble is trying to show you with factor by grouping is this. So like the first two terms have A and B, but they share R in common. The second two terms also have A and B, but they share S in common. So what we do in factor by grouping is we say, let me factor R out of the first two terms. Let me factor S out of the second two terms. So that's like taking out their GCFs. And then at the end, we're going to basically like undistribute. It must have been these two things as a single factor, R plus S times A plus B. Like I distributed the R to the A plus B, and then I distributed the S to the A plus B. Okay. Let's see it in action here. Move all this up so I can see that better. We're going to do x cubed minus 2x squared minus 9x plus 18. So, I mean, obviously this one has how many terms? 4. We're going to try to factor by grouping. Before I do factor by grouping, I might check to see if they share anything in common. They don't all have x. They don't all have a factor of 2 or anything like that. So I'm just going to split it down the middle and see if it factors by grouping. So in factor by grouping, you ignore the last two terms. Just look at x cubed minus 2x squared. What do they have in common? X squared only. The 2x squared doesn't have an x cubed. So we'll take out an x squared. What's left over is x minus 2. So you're taking the GCF, greatest common factor, out of the first two terms. Okay, now, when you do the last two terms, always like whatever sign is in front of the third term, that sign is going to be out here. If there's nothing that you can take out of both terms, you'll either have a +1 or a -1 out there. Okay. But when you look at 9x and 18, can you take anything out of both of those terms? Yeah, you can take out a 9. What we're really going to take out of both of them is a -9. Okay, so you're always going to take out this sign, whether it's plus or minus. Okay, and that'll help you. So, like, what's left over? Well, -9x divided by -9 is now a positive x. And a positive 18 divided by a -9 is a -2. Do you see these two groups of parentheses are exactly alike? X minus 2 and x minus 2. That has to be true for it to factor by grouping. If those two things are not exactly alike, like one was x plus 2 and one was x minus 2, you would say not factorable. So in order for it to factor, they have to be exactly the same. Now, if you got one that was x plus 2 and one that was x minus 2, I would go back in my work and double check if I have a sign error. I'm going to think it's me maybe at that point. But if one is x plus 2 and one is x plus 5, maybe it just doesn't factor. Question? Okay. So now that those two match, that's one of your factors. So you only write that factor one time because you're undistributing it. Your other factor is made up of these coefficients or greatest common factors that you took out. So my other factor is x squared minus 9. What do you notice? X squared minus 9? That's a difference of perfect squares. So this is really x minus 2 times x plus 3, x minus 3. So this is what we would say is completely factored. It's factored all the way. Like,
With the x minus 2, because you're like combining it, would it be x minus 2 squared?
no. What you're really doing right there is like, it's like undistributing. So like say we had x squared minus 9 and it was being multiplied by x minus 2. What we're doing right there is we're saying take like the x minus 2 as a whole term and multiply it by x. So that would be x squared times x minus 2. And then take this whole thing right here and multiply it by -9. So that would be minus 9 times x minus 2. So you're basically going backwards. You're undistributing the x minus 2. Yep. Okay, any questions about factor by grouping? That should be one that you have seen before. Okay, be on the lookout for 4 terms. That's assigned to factor by grouping. Last one, trinomials. Now, notice in the trinomials bubble, I didn't give you any real rule, right? I just listed out what examples of trinomials might look like. Ax squared plus bx plus c, we saw that a lot in quadratics. But I could raise my exponents now that I'm working with polynomials and I know about quartics and quintics and 6 degrees. So it could be ax to the 4th plus bx squared plus c, or ax to the 6th plus bx cubed plus c. So I can factor all of those. What I'll say for you on this one, if you're using a box method or a cross method or X method, remember we talked about that in chapter 3, that's okay. If you have a method that someone taught you that you like, you can use that for factoring. Ms. Cronky uses guess and check. And the most important part of that is check. Okay? If you're just guessing, there is a chance that you are wrong. And so you need to check to make sure you are right. Okay, so let's look at the examples on this one real quick. 5x to the 6th minus 24x to the 4th plus 30x squared. What do you notice about all 3 terms? You can take out a 5x squared. So let's take out the GCF first. That leaves me with x to the 4th minus 5x squared plus 6. So I got 3 terms right there. As long as your first term's exponent is double your second term's, and then you have a constant, like there's a good chance that you could factor that. Okay. If it was x to the 4th and an x cubed, we probably wouldn't be able to factor. Okay. So I'm going to go ahead and put out my 2 groups of parentheses. Now to get x to the 4th, it could have been x cubed times x. It could also be x squared times x squared. Based on my middle term, it must be x squareds, right? Like I need x squared as my middle term. So I'm going to put my x squareds in. Okay. And I'm checking as I'm guessing these things, like x squared times x squared would give me x to the 4th, right? So that part checks out. And then I go to this last number, 6. What are some factors of 6 that you know? 2 and 3, anything else? 1 and 6. Okay? Because they're both positive, or because this value is positive, that means they have to have the same number. They're either both positive or both negative. Okay? Which means you're really adding the values. Would 1 and 6 add to make 5, or 2 and 3 add to make 5? 2 and 3, so I'm going to cross off 1 and 6. It actually needs to be a negative 5, so both of those must be negatives. Negative, negative. So I'm going to put in a minus 2 and a minus 3. But remember, I just guessed that, so I'm going to also check it. Okay? So checking should take about 20 seconds. X squared times x squared is x to the 4th. I'm going to do my outside and insides together. Negative 3x squared, negative 2x squared, makes negative 5x squared. So that part checks. And the last term, negative 2 times negative 3, plus 6, it checks. I might notice that x squared is a perfect square, so I might check these, but 2 and 3 are not perfect squares, so I don't have to factor anymore. It's done. It's completely factored. Okay. All right, see if you can try 2x to the 13th plus 10x to the 9th plus 8x to the 5th. I'll give you a minute. See if you can guess and check that for me. Did you take out a 2x to the 5th? Check for a GCF first. Okay. That'll always make your life easier if you can find a GCF because your numbers will be smaller and easier to factor. Okay, so take out an x to the 5th. Sorry, my 5 looks pretty bad on that one. Since the first term is twice that of the middle term's exponent, I'm thinking it might factor. What would you choose for your first terms? X to the 4th. Because then when you multiply them together, you'll add them to get x to the 8th, and our outside and our inside terms will be x to the 4th, which is what our middle term is. What are some factors of 4 that you know? 2 and 2, 1 and 4. It's positive, so they have to be the same sign. Which ones are going to add to make 5? The 4 and the 1. Since it's a positive 5, they should both be positives. Positives. Okay. Plus 1, plus 4. Okay. That way, when I check it, x to the 4th times x to the 4th is 8x, or is x to 8. 4x to the 4th plus 1x to the 4th is 5x to the 4th, and 1 times 4 is 4. A lot of times people do this. They say 1 and 4 makes 5, and then they drop 1 and 5 in. You can see how these are really easy to get your numbers muddled. So you need to make sure that you're checking those at the end to make sure that they are the trinomial that you said it was. Okay, your homework is practicing with factoring. I've got it on my list of things to do to find some good internet factoring practice, because I mentioned that back in chapter 3. If you don't feel comfortable with factoring, you need to do more practice. You need to get some more time with those factoring. So I'm going to look for that, and I will post it online. That's fine. I'll post it online as soon as I can. Okay. We'll go over questions from factoring at the beginning of class tomorrow. And then we continue. You have to be able to factor so that we can do the factor theorem tomorrow. So make sure you come with questions. Probably most questions are going to be, I would guess, grouping, trinomials, and some are difference of cubes. I always think difference of squares is probably the easiest one. Mm-hmm. Yes?
What time do you have to come tomorrow?
I would give yourself more than half an hour. I don't know that you're going to be able, that's the same amount of time as Titan time.
Okay, well then,
So I would say 7:15.
okay, do I need to pass then?
I can write you one.